The next data reference I'll discuss is the table lookup data reference. AF has the ability to save data in tabular form internally, and using the table lookup data reference, we can run SQL-style queries against these tables to return a value for our attribute. The reason we'd want to do this is because the tables saved in AF can be populated with data from sources external to the Pi system. In the following set of videos, you learn how to build or import tables into an AF database, and also how to use a table lookup data reference in order to reference tabular data through an AF attribute. For example, we may have a table of nameplate type data that's produced by our maintenance department and held in an external SQL server or maybe in an Excel spreadsheet, and we'd like to import that data into AF so that we can use it to help define our assets. That way, if I return to my completed HVAC system, we can see this equipment metadata right alongside our real-time tag data and other calculated attributes in order to facilitate comparisons between different pieces of equipment, for example, across manufacturer or across installation date. These external sources could be something like a maintenance or equipment database saved on a SQL server, or a spreadsheet that lists material properties for inputs to our process. By adding this so-called metadata, we can create a fuller model of our assets and give context to the time series data coming from the Pi data archive. In order to access the table database for editing tables or creating new tables, we need to look in the library. So going over to the Navigator panel, click on Library, and you'll see there's a section for tables. Now currently I don't have any tables created, so we'll go through the process of creating a new one. So I can start by going here and clicking New Table, or like many other parts of Pi System Explorer, I can right-click and I have an option to create a new table. Now the table I'm going to use for reference is a simple example that I've created called Zone Information Tables. And here we have a table of the square footage of each zone within our research lab. So for such a small table, I'm going to first create this one by hand so we can see how that's done. First I'll start by giving our new table a name. I'll call it Zone Areas. I'll give it a description. And again, I can add a category if I'd like. Now the first thing we'll notice is that there's options for importing and linking. We'll discuss those in a minute, but these are ways to bring in tables automatically from an external source. Next I'll go to my Define Table tab. And this is where I'll define the columns for my table. Now looking back to my Excel table, you can see that I have two columns, zone and square foot. For data types, it looks like these would be integers, and these would be integers as well, but in case we ever get square footage with a decimal, we'll go ahead and use a float type number for defining this column. So returning to PSE, I can click here to create a new row. So now I need to define the columns for my table. I can either go here and use this Create New button, or again, I can right-click, select Insert. So I'll call my first column Zone. We determine the value type, should be an integer. We won't worry about any type of unit of measure or time zone for that. We'll insert another column. I'll call this one Area. And we decided that would be, I think single would be sufficient for that. And the unit of measure we need to add. We want to go to the area class and find square feet. So now we've defined the columns for our table. If you go back to the table column, you can see that now I have my two columns available. Since I've defined the columns with their data types, I can actually go to my Excel table, copy my data, and paste it directly into the AF table. Now I have everything I need to define the table. Go ahead and click OK. And you'll see that my new zone areas table has now been defined. So I'll go ahead and check that in. Now that we have our table defined, we'll want to use the table lookup data reference in order to bring the data into our attribute. So I'll go back to the elements view. I'll add a new attribute to zone 1. And I'm going to call this area. And it's going to be a table lookup. When we go to our settings, see the first item at the top, we can select which table we want to use. Here we only have one table to choose from, but if you had multiple, they would all appear in the list. Next, we want to select our result column. And here we want to return the area from the table, so the result column is already set correctly. In general, you can keep the default behavior. The next step, we're going to define the where clause for our SQL statement. This will help us filter the data and return only the value that we want. So here we want to match the zone column to the zone number attribute. So I'll hit add an AND clause. Now when the query is run on the table, it'll find the row where the zone number attribute matches the zone number in the table and return the area that appears in that row. So I'll click OK, and you'll see that by using the settings GUI, the SQL statement has been defined for us, and this form should look familiar to those of you who are SQL users. Notice here that the area for zone 1 has been returned as the attribute value. Looking back to our table, see that zone 1 has an area of 10,250 square feet, and that's exactly what is returned for our table lookup data reference attribute. I'll go ahead and check this in, and we'll proceed to the next step. Previously we saw how to create an internal AF table by hand, but I also mentioned that we could import this table automatically from an external source. So let's see a quick example of how to do that. Now for our zone areas table, we create our table by hand and simply copy and pasted the data from Excel into our AF table. To see how we would import that, I'll first build a new table, and we'll call this one Zone Areas from Excel. I'll start by clicking the Import button, and you'll see that we need to first define a connection string so we can connect to our external data source, and then we'll also need to define a SQL style query so that we know which data we'll be pulling in from this source. So I'll start by hitting the Build button, which will take us through a GUI that helps us build the connection string. And the first thing you'll need to do is select an OLADB provider for your external data source. And I'll note that not only do you need to use the correct provider, you also need to use the correct bitness for your data source. In this case, I'm using a 32-bit version of Excel. So I'm running the 32-bit version of PySystem Explorer, which will give me the correct bitness for my driver. In a minute, I'll show you an example of what happens if we were to use the incorrect bitness. So here I know that this driver works with Excel. I'll go ahead and hit Next. The data source, I'll use Excel files. And then it asks me the initial catalog. This is equivalent to which database we would want to choose on a SQL server. In the case of Excel files, we want to use the file path to the Excel file. So I'll jump over to Excel real quick. You can easily get that file path here. Another thing I want to take note of while I'm in Excel is the name of the sheet where the data is located. In this case, the name of the sheet is Area, and we'll use that in a minute with our query. So now that I have the path for the Excel file, I'll enter it in the catalog field, and then we can use this button to test our connection. And looks like everything's good to go. So I'll click OK. Now I need to enter my SQL query. So like a standard SQL query, I'll start with a select statement. And in this case, I'll just use star because I want to grab everything from that sheet. And then we'll have a from statement. And this is where we need to enter our sheet name. For this particular OADB provider, the sheet name has a particular syntax. It's open bracket, then the sheet name, then a $sign, and a closed bracket. So go ahead and click OK. We don't get any errors. I'll go and check my table, and you can see that all that data has been imported from the Excel sheet into AF. I'll jump over to the Define Table tab, and we'll see that in this case, when AF imports the data, it makes its best guess at what the data type is. Since we don't have strict typing in Excel, it's just used double because we have numeric data. Previously, we had defined our zone to be an integer, so we can change that here if we want. And we can also add a unit of measure for the square footage, because obviously there's no way to define units of measure that can be translated from Excel into AF for this import. So again, I'll go down and select square foot, and now we have our imported data from Excel in our new table. I'll go ahead and check that in. I also promised you that I would show an example of what happens if we were to use the wrong bitness for our OADB provider. Here, if I go and open up the 64-bit version of PSE, and if I go to my imported data from Excel, use my import button, my build button, and I use my test connection again, you'll see that I get an error that the provider isn't working correctly. And you can see it's the exact same provider name. The only difference is that here I'm using 64-bit instead of 32-bit. And since I have a 32-bit version of Excel that I'm trying to import from, the provider has a conflict. So just something to check on if you're getting errors when you're trying to set up your imported table. Next, we'll look at a quick example of how to import data from a SQL table.